Hi, welcome back to our series on robotics with Arduino. I am Jason Vasalia, and for this experiment, we will be controlling the angular displacement of a servo motor using an ultrasonic sensor and displaying their readings and angles on the LCD as well as the serial monitor. Alright, so our objectives for this experiment is to know how ultrasonic sensor works and program it to work in a microcontroller. In addition to that, we will also be controlling a servo motor based on the distance that the ultrasonic sensor is reading. Alright, so for our materials, we will be using the breadboard, servo motor, jumper wires, Uno board, the ultrasonic sensor, as well as an LCD display. So again, our servo motor that we will be using for this experiment is the SG90, which has a pulse width modulation at orange wire, the VCC at the red, and the ground at brown wire. So the ultrasonic sensor that we will be using is the HCSR04, which has a working voltage of 5 volts and a measuring angle of 15 degrees, a trigger input signal of 10 microseconds, TTL pulse, and an echo output signal or input TTL lever signal in the range in proportion. We will also be using the LCD with a built-in or with an I2C module that will make it easier for us to control and wire to the Arduino. So the board that we will be using is the Arduino Uno 3, and we will be utilizing the pins 10, 11 for the ultrasonic sensor, the A4 and A5 for the I2C communication of the LCD, and the pins 3 or the D3 for the pulse width modulation of the servo motor. We will also be using the ground as well as the 5 volts. Okay, so for the schematic diagram, as you can see here, we have the HCSR04 again with its echo connected to the pulse width modulation D11, as well as the trigger pin connected to the D10, and the VCC. All of the VCC that you can see right here in the screen is connected to each other, which is connected to the 5 volt supply of the Arduino. And the ground pin is also connected. Everything that you can see right here, every ground that you can see is connected to each other. And the pulse of the servo motor again is connected to the D3 for the pulse width modulation. And for the I2C that we will be using, we have the clock, the SEL or the clock connected to the A5, and the SDA for data is connected to A4. For the circuit assembly, we have this right here, which is very close to what you will be seeing later on when we actually do the assembly and or the actual physical assembly as well as the demonstration. So right here we have the ultrasonic sensor at the bottom part, which is connected to the breadboard, as well as the servo motor with all of the ground and VCC connected to one another at the top part of the breadboard that you can see on your screen. And the 5 volt is of the Arduino is connected to the VCC line of the breadboard, and the ground is connected to the ground. And it's basically the same as the schematic. This is just a visual representation of everything that you saw. Alright, so for the programming and demonstration, we will show you the sped up version of me coding as well as the demonstration after. We'll also show you how we did the Fritzing for the schematic and the circuit assembly. Alright. Alright, so now that we have finished the program, as usual, let me walk you through the entire code. Alright, so as you can see here, we have here a couple of preprocessors. We have 4 additional libraries, excluding the Arduino.h. For the first one, wire.h, this is for the I2C, I2C communication for the liquid crystal display that we have. And for the second one, the servo.h is for our servo motor, for controlling our servo motor. The third one is for the liquid crystal display with I2C communication itself. And the fourth one is for our ultrasonic sensor. Alright, so right here we have created 3 macros. The SMP, which stands for servo motor pin, which is at pin 3, and the TR and the EC is for the ultrasonic sensor. TR stands for trigger and EC stands for echo. So the trigger pin of the ultrasonic sensor is connected to the pin 10, and the echo is connected to the pin 11 of the Arduino. So I've also created a max underscore cm or centimeter, which has a value of 31, and that is for our ultrasonic sensor later on. And right here, I have also created 2 function macros. The first one is for the LCD print, or the L print, which accepts 2 inputs, A and B, where the A is is for the what do you call this, the sensor value, and the B is for the angle of the servo motor. It will print the distance as well as the angle right here, as you can see. And the LCD.set cursor 0, 1 will make the next line printed on the second line of the LCD. And here, right here, the S print or the serial print also accepts 2 variables or 2 inputs, A and B, where the A is still again the sensor value, and the B is for the conversion of that sensor value into servo angle. Right here, I created this print where it prints distance plus the string, the sensor value, and the angle plus the string B or the converted value. Right here, we have created new class objects. For the first one, the new ping, or for the library of the ultrasonic sensor, we named it sensor. It accepted a value of a trigger for first the trigger pin, the echo pin, and the max centimeter that we will be using it for. In my case, is 31 centimeters. And for the second one, liquid crystal I squared C, we have created a new object called LCD, and this part, the 0x3f, this is the address of the I squared C communication that is present in our Arduino for the LCD. And the following numbers are for the configuration of the I2C module to the LCD display itself. Alright, so another one is the servo, and we named it servo. And I've created a new 8-bit integer underscore t called print c, which is equal to 0 or has an initial value of 0. For our void setup, we have here our serial.begin, which has a baud rate of 9600. This initializes the communication between the PC and the Arduino. And the servo.attach, that will initialize the pin where the servo is connected to. And the LCD.begin will initialize the LCD. So for a void loop, we have here if print C is equal to 5, and as I mentioned earlier, we have initial value of 0 for the print C. This is for the print control, where it will print it will print everything to the LCD and the serial once this condition is satisfied. So why did I put this here? It's so that it will not how do you put it? It would not overprint, like it would not spam the serial monitor, and that will happen every time that it increments or it reaches 5 by incrementing it by 1 every time this loop continues or goes on. So we have here the servo.write, where it writes the value, the integer value to the servo motor, and that value will be the basis for the angle of the servo motor. And right here, the map function, this will convert the sensor.ping underscore cm, which is the ultrasonic sensor reading, which has a value of bit 0 to 31, and that will be right here. The argument will be 0 to the max cm 31 and 0 to 180, or the maximum angle that the servo motor can do. The next is the print C++. Again, it will increment until it reaches 5. It will print the values to the serial monitor as well as the LCD. And right here we have a delay of 100 milliseconds. So actually, for the first part, let's only do the serial print. Let's comment this out first. Okay, so we can focus to the serial monitor. Alright, so let me start the program. Let me upload this. Alright, so as you can see, it's uploading. Let's just wait for it to finish. Now if I open the serial monitor, as you can see here, it starts to print. And if you see right here, I've already set up everything. So if I try to place an object in front of it, let's say at around 30 to 31 centimeters, as you can see, it prints 30 as distance and 174 degrees as angle. So if I put this closer and closer to the ultrasonic sensor, as you can see, the reading starts to decrease and the angle also starts to decrease to 98 degrees, 92, 87. The distance starts to decrease as well. And if you notice, there's nothing printed on the LCD yet because we haven't we commented this function that will print everything on the LCD. We will do that later. So right here, as you can see, it goes on and on until it reaches a value of 0 distance. Alright, and also notice the movement of the arm of the servo motor. As it goes farther, it comes closer to a value of 180 degrees, and if I put it closer, it goes to 0. Alright, so as you can see, the arm of the servo motor starts to move as soon as I move the object in front of the ultrasonic sensor. So now that we have tested that and the serial monitor, let's try to do it with the liquid crystal display. So again, let's upload this to the Arduino. Alright, and open the serial communication so we can compare their values. Alright, so as you can see, it has a reading of 0. It's not detecting anything since we haven't put any object in front of it yet. But once we again start, it detects a value, or it reads a value of 29 centimeters, 174. Notice also that it's printed out in the LCD. So if I move it closer and closer, let's say at around 150 centimeters or 150 millimeters, which is equivalent to 15 centimeters right here, the servo motor arm is approximately at 90 degrees or 87 degrees actually, as it's printed in the LCD as well as serial monitor. So if I move it closer and closer, it still moves, it still works. Notice that the value in the LCD also changes. Also notice that every time that the servo motor moves, it doesn't always print the value in the serial monitor as well as the LCD. This is because of this function, of this if function, which only prints every 5 reading of the ultrasonic sensor. So as you can see right here, it's working properly. Alright, so for an additional, I created a graphical user interface for this program. So the only thing that I actually changed in our Arduino program is that for the sprint function, it no longer accepts 2 inputs. It only accepts 1. And that 1 input will be the sensor reading from the ultrasonic sensor. And it will be converted into string, which will be printed to the serial port. So that's the only thing that I changed. Now if we go to the Visual Studio right here, as you can see, I created a couple of functions. So first, let's discuss the design. So as you can see here, I placed a serial port for this GUI, and this is or I first created these 2 labels as well as the 2 text box. As you can see here, we have a progress bar, and this progress bar has a maximum value of 31, which is equal to the maximum value of our sensor and Arduino. So what this does is it displays a progress between 0 to 31 centimeters, depending on what the serial port is receiving from the Arduino. So right here, the text box, the first text box receives the input from the Arduino, which is the sensor reading from the ultrasonic sensor, and the second text box is the converted value from distance to the angle of the servo motor. So I actually copied the map function from Arduino that you can see right here, map. So this function is what converts different ranges to a certain range. So right here, I copied this, created a new function called public long map, which is equivalent to the Arduino in C++. And right here, I first created a serial or a public delegate void d1 string and data for the data that will be receiving from the serial port. And right here, we initialized the serial communication through serial port 1.open, and right here, serial port 1 data received. What this does is it invokes, or it calls out this function, which will be the function that will process our data. So the write to form is going to print out the value or the in data plus centimeters in the text box 1, and the progress bar 1 value will convert first the in data into an integer, and it will display that integer in the progress bar. So right here we also called the convert to string or convert to integer. The in data will be converted into an integer, which will be an input for our map function in converting the range, and that will be converted, everything will be converted into string and will be appended by degrees, and the entire thing will be displayed in the text box too. Right, so to see that working, let's start this. Alright, so as you can see right here, we don't have any values yet. It's set at 0 centimeters and 0 degrees. This is because we don't have any object in front of the ultrasonic sensor yet. But once we place an object, as you can see, the sensor reading read 28 centimeters, which is also displayed on our graphical user interface. And if I move that closer and closer, as you can see, also the progress bar is getting shorter and shorter, and everything is being displayed on the GUI. Alright, so notice also that the LCD is displaying the same thing as the GUI. Alright, 9 centimeters, 52 degrees. Alright, so that will be it for our experiment. See you on the next one.